Hi dear students, welcome to my channel Tech Tutorials 2K21. So today in this video, I'm going to explain how to implement a stack operations in C programming. So before getting explanation of this program, you have to know what is stack and what are different operations performing on stack. So come with a definition of a stack. A stack is a linear data structure which follows last in first out manner. So last in first out means what? So whatever the element we are inserted into a stack last, that can be deleted first. So there are two operations we are performing on stack. One is push operation and the second one is pop operation. So push operation is inserting an element into stack and pop operation is deleting an element from stack. So for doing these two operations, we have to check two conditions. For inserting an element, we have to check whether stack is empty or whether stack is filled. So when we are going to insert a new element into stack, we have to check your top of the stack position will reaches the maximum position. If it reaches the maximum position, we cannot place a new element into stack. That condition is called stack overflow because it already reaches its maximum size. I cannot insert new element into that. Now the second operation is pop operation. Now that is nothing but deleting element from the stack. So whenever we want to delete an element from the stack, we have to expect that something will be there in a stack. So if stack is empty, then we cannot delete anything from the stack. So that condition is called underflow because when I'm trying to delete, I can't delete the item from the stack because the stack is empty. So these information we are going to see how we are going to implement this program in C language. And here I used an IDE which is called Dev C++. I already built a project that is in C, and here I pasted my entire program. Now it is a menu driven. So now you can see a menu is displayed when you are executing your program. So whatever the option you want, you can do it. So whenever you say exit, then only it is come out of the program. So and in this program, we are implemented in a modular wise, means every operation we are implemented through a functions. So this is very simple program. Try to understand this. If you have any doubts regarding this program, you can ping me in my chat box. So definitely I will clarify your doubts. So now you come to see in this green letters what you are finding. These two is called header files. Now you can see standard input output header file and standard lib.h header file. And these two header files are supported to perform your um, stack operations in C programming. Now this is a constant. That's why we are using hash defined preprocessor and we are taking stack maximum size is 5 because here we are implemented stack in a static implementation, means we already fixed the size of the stack, then we are performing this push and pop operations. Now you can see these three are the function declarations. So now I'm using three functions: push for insertion, pop for deletion, and display is an operation which is going to show you all the elements of your stack one by one. For that purpose, here I'm using three functions. Now you can see this is your stack declaration, means I'm taking one array. My array name is stack, and the maximum size is 5. You already seen here my maximum size is 5 I'm given, so it will take the maximum size is 5. And in stack implementation, the top of the stack will place the key role. It's like a pointer. So it always starts with -1 that indicates your stack is empty. Because at the first time when you are creating your stack, obviously it is empty only, right? And afterwards, this is a stack implementation with array so that the index starts from 0. Now in the main function, so because this is a menu driven, So I'm implemented using switch case. So here I'm using while because this menu is going to be displayed until you say exit. So that's why here we are taking a loop while. So within brackets we are specifying one means it's true. While true, then you are going to display this menu on my screen. So what it says, this menu say like static implementation of stack, and then one is for push operation, two is for pop operation, and three is for display. And if you press 4, then it exits from the program. So after that, now it will ask to enter your choice. From 1 to 4, you can enter any choice, and that can be read by this scanf statement. And after that, we have to use a switch case. So in this switch case, we simply call the functions because the function definition is having the original functionality. In main function, what simply we will do, we just call the function. If user enters case 1, I just want to execute push function. So that's why here it is given. I'm calling push function and my case get break. In a similar way, case 2, we are performing the pop operation and break. Case 3, we simply call the display function and break. And case 4, we want to exit from the program. So that's why here in exit function, we are passing value 0. So now this 0 is given to your while function, then it becomes false. So when it becomes false, it doesn't show you any menu to display. So suppose if user is not given a choice in between 1 to 4, what simply we are given like we are showing like it is an invalid choice. So this is about the main function. So I think you people know in C programming, the program execution is starts from the main function. Because of that reason, I explained the main function first. Now you simply understand that your main function will consisting the menu driven and all your switch cases like case 1 we are calling push operation, case 2 we are calling pop operation, and case 3 we are calling display operation. Now it's time to implement all your functions. So here are three function definitions. So here see this is my first function. So here you can see this is my first function. Now I want to do push operation. So for that, this is a function definition. So now suppose if I want to push the elements, what I need to do, I have to read the number and I will take my top of the stack position. There I need to insert my value. So for that here we are taking three variables, number, n and I. So here this program is implemented in such a way that it will ask you how many elements you want to insert into your stack. Because you are creating a stack, you can insert number of elements whatever you want. So that's why here it will ask you like the number of elements to insert, and thereafter it will take one by one element and it will place into your stack. So I already informed at the beginning, whenever we want to performing a push operation, we have to check whether we have some space in the stack. So that's why here we are checking a condition if top of the stack is reaches the maximum size. Because it is implemented with array, we know array index starts from 0 and it reaches the maximum index is maximum size minus 1. So if your top of the stack, it reaches the maximum sizes minus 1, that indicate your stack is full. So we cannot perform any push operation. So if this condition fail, now you can see it is a condition, it will check if your stack is full. It doesn't prompt you how many elements you want to insert. So now if your stack is not full, so you have some space, it will prompt you enter the number of elements you want to insert, and that number it can be read by using a scanf function. Thereafter we will check your number means the maximum number of elements you want to insert, you are given n value na, that it will check with the maximum size, because always the number of elements to insert is must be less than to your size of the stack. So if this condition satisfied, then the loop gets start executed. Now it starts from 0 and it will take up to n, because if you are given 3 elements you want to insert, then your loop will run for 3 times and it is going to read 3 elements and it will place onto the top of the stack. So it will ask the element to push into stack. So that element we are given by using your scanf statement. And then your top of the stack position will get increment because initially it will be -1. So now you are incrementing top of the stack means it becomes 0. So what this line of the statement will do, stack of 0th position, whatever the element you are given, that will be inserted. Again remember, you are in the for loop. So now what it will do, your I will get increment. Now it becomes 1. So 1 minus n, if condition true, so then again it will ask you enter element to push into the stack. Again your top stack of the position will get increase and the element is inserted into your stack. So this will be continued. The number of elements you are asking to insert. So if this condition fail, means what? Whatever the number you are given, these many of elements I want to insert into my stack, and that will be greater than to your stack size. Then simply it will say number must be less than the stack size. So this else case will execute when this condition fails. If this condition is true, then it will take the element one by one and it will place into your top of the stack of your stack. So this is your first function, and then we'll go with the definition of the second function. So what is the second function? Pop operation. Pop means what? We have to delete an element from the stack. So whenever we want to delete an element from the stack, we have to check whether something is there in the stack. If nothing is there, we can't delete any item from the stack. So for that we have to check here a condition if top of the stack is -1. So top of the stack is -1 means what? Stack is empty. So when a stack is empty, that condition means when stack is empty, you're trying to delete something from the stack. That condition is called stack underflow because I cannot delete anything from the stack. So if this condition not satisfied means what something is there in your stack, then what we have to do? Always you remember we are performing either insertion operation or deletion operation. We are taken from the top of the stack position only. So if you have something into top of the stack, now you can retrieve that value into one variable num and that is going to be displayed by using this printf statement. Means element pop from the stack percentile d is nothing but what element it is deleted from the stack, that is going to be displayed by using this printf statement. And after that, your top of the stack position will get decrement so that we can see the next element of your stack. So this is a pop operation. So we can delete only one element at a time into stack. And after that we have a third function called display. So by using this display function, we are trying to display all the elements which is available in your stack. So for displaying also, we have to check whether your stack is empty. If your stack is empty, nothing is going to display. So what we have to do, we will check top of the stack is -1. Simply we say stack is empty. So that it is going to display. Otherwise, it using for loop. Okay, for I, it starts with your top position and then it is going to take an element from the top of the stack position and it is going to display by using this printf statement. Now you can see stack of percentile d. Suppose you have 5 elements in the stack. The last index it will be 4. It will show you like stack of 4 is equals to whatever the value that is going to display. So for that we are using this one. So now up to what you have to run your for loop, because you are starting from the top of the stack, it will reach until 0, right? Until 0. As of now, you have the elements into stack, so that it is going to display all your stack elements. So this is about this program. Now I'm going to show you how we are going to execute this program. So simply in dev C++, we have this execute tab, we have compiler and run option is there. Just you simply click on that. Now it will ask you like here I'm given same program name. Okay, yes, you can say. And now it is going to, okay. So here itself we have to uh, declare this variable first. So like this we have. So now you can say I value. So again I execute this program. So now you can see this is my executable file. So here it will ask me enter your choice. So I choose my choice 1. So now it will ask enter number of elements wants to insert. Now I just want to insert 3 elements into my stack. So I am giving 3. So it will ask enter the element to be pushed into the stack. I will give in 45. Then again it will ask I will give in 85. And again it will ask I will give in 96 because I asked to insert 3 elements. So now you can see all these 3 elements are inserted. I want to see whether it is inserted or not. So simply I am taken an choice 3. So it is going to display. So now you can see stack of 2 equals to 96, stack of 1 equals to 85, stack of 0 equals to 45. You can observe this output. So which element I inserted first? 45. What I said at the beginning, your stack is LIFO, means last element is deleted first. Which element I inserted last? 96. Now you can see in display, you can see 96 first. See here, 96 that I inserted last, that I can see first. So now I'll go with the pop operation. So as per the definition, what it will do, the element I inserted last as 96, that is going to be deleted first. So now I'll go with an option 2. Now you can see that element pop from the stack is 96, right? So that will be the last element which I inserted. So this is about stack implementation using C. I hope you people understand. If you have any queries on this program, you have to put a message in my chat box. Thank you.